Welcome to manoharchemistry YouTube channel. So today I am going to explain Bohr atomic model. So what is Bohr atomic model and what is the postulates in Bohr atomic model, that all things we are going to discuss in this. One atom is there. In an atom, nucleus will be like this. So around nucleus these orbits will exist. So this is first orbit and this is second orbit and this is third orbit and this is fourth orbit, like this. So we can give names of these orbits like this. So this is one first shell and second shell, third shell and fourth shell. So n is equal to 1 here, n is equal to 2, n is equal to 3 and n is equal to 4. Or we can simply call them as K, L, M and N, right? So within an atom, within atom orbits will be there. These orbits are circular, these orbits are having circular manner around the nucleus. So when electron is revolving in these orbits, electron neither lose energy nor gain energy with this particular orbit. For example, one electron revolving in a fourth orbit, in this with respect to fourth orbit only, it will neither lose energy nor gain energy. But when it reaches from one orbit to another orbit, so based on their energy levels, it may lose energy or it may gain energy. But when electron is revolving only in one particular orbit, in such case, it will not lose energy, not gain energy. So once again I am repeating here. The electrons in the hydrogen atom revolves around the nucleus in a circular path of fixed radius and energy. So means these circular paths having fixed radius as well as energy also fixed for these circular paths. These paths are called orbits. So these paths only we call it as orbits, and stationary states also. One more name also is there. We can call them as a stationary orbits as well as what? Stationary states also. For electrons are numbered. So these are numbered as n is equal to 1, 2, 3 or designated as K, L, M, N also. And these shells are named as like this. These integral numbers are known as principal quantum numbers. These integral numbers only known as what? Principal quantum numbers. These orbits are arranged concentrically around the nucleus. So what is the state? Electron in the hydrogen atom revolves around the nucleus. Electron in the hydrogen atom revolving around the nucleus in a circular paths. These circular paths are called stationary orbits or stationary states. Why we call them as a stationary orbits and stationary states means they are fixed. These orbits are fixed. They are having fixed energy as well as fixed radius. In these orbits, electron is revolving continuously. When electron revolving in that particular orbit continuously, in such case, electron neither lose energy nor gain energy. So that's why we call them as a stationary orbits and stationary states. These orbits having specific names for them. So which is near to the nucleus is having 1, which is little bit away from the nucleus is having 2. So first shell, second shell, third shell, fourth shell, like this. And n is equal to K, L, M, N. These type of shells are having different types of names. So this is first postulate with respect to Bohr atomic model. In first postulate, we have seen electron will be revolving around the nucleus in a circular path. So these circular paths are called orbit. But here electron will not revolve in every circular path. So there are n number of circular paths are there, but in every circular path electron will not revolve. So in which orbit electron will revolve? For that one condition is there. If that orbit satisfy that condition, then only electron will revolve in that orbit. So that second concept will explain that condition actually. So here, if any substance, if any object is moving in a linear motion, then we call it as what? Is moving in linear motion. Then we can calculate the momentum. That momentum is called linear momentum. When any substance is moving in a linear, then we call it as what? Linear momentum. But electron is not moving in linear direction here. Electron is revolving in a circular manner. So when electron is revolving in a circular manner, then we have to calculate its momentum. But that momentum we call it as angular momentum. Why? Because electron is revolving in a circular manner here. So that's why we have to call that momentum as a angular momentum. For angular momentum formula is there, we have to calculate by using this formula, MVR, mass into velocity into radius. The product of mass, velocity and radius, we call it as what? Angular momentum here. This is not linear momentum. So what is that condition actually? Which condition has to satisfy by the electron to revolve in a circular path? So that electron revolve only in those orbits where angular momentum of the electron is quantized means quantized means having fixed value. Okay, Thus, an electron can move only in those orbits for which its angular momentum is an integral multiple of h by 2 pi. Means which orbits angular momentum, which orbits angular momentum MVR value should be integral multiple of h by 2 pi. Integral multiple of h by 2 pi. Integral multiple means here we have to take n. Means what is meant by integral multiple? So for example, what is multiples of 2? So we will write like this: 2, 4, 6, 8, like this we will write. Means here 2 into 1. So 2 into 2. So 2 into 3. 2 into 4. This is what multiple of 2. So means integral multiple of h by 2 pi means what we have to write? First orbit is h by 2 pi. Second orbit is what? 2h by 2 pi. Third orbit is what? 3h by 2 pi. Fourth orbit is 4h by 2 pi. This indicates what? Integral multiple. For n integral multiple of h by 2 pi means up to n orbits we are taking, then nh by 2 pi. Integral multiples of h by 2 pi means this. Means for first orbit, electron which is revolving in first orbit, so in that orbit the mass of the electron and velocity of the electron and the radius of the orbit, the product of these three will become equal to what? H by 2 pi. When you go for second orbit, in second orbit, mass of that electron and velocity of that electron and second orbit radius, the product of mass of the electron, velocity of electron and the radius of the second orbit value will be equal to what? 2h by 2 pi. Then only if that second orbit will satisfying this condition, then only the electron will be revolving in a second orbit. If not, it will not revolve in a circular path. Means electron will not revolve in a second orbit. In case of third orbit also, if electron want to revolve in third orbit, then third orbit radius and mass of the electron and velocity in that orbit will be equal to what? 3h by 2 pi. So then only electron will be revolve in third orbit. Similarly, up to nth orbits we have to follow this condition. Which orbit will not satisfy this condition, then electron will not revolve in that orbit. Okay. So next point is the energy of an electron in the orbit does not change with the time. Means when electron revolving in a circular path, then electron energy will be not changes with respect to time. 1 hour the energy is 10 kilojoule per mole. After 2 hours the energy will not become 20 kilojoule per mole. So energy will remain constant throughout the atom in particular orbit. Energy will not change with respect to time. This means that energy of an electron in the particular orbit, energy of an electron in a particular orbit remains constant. So what I am saying, energy will not changes. Energy is not changing, so that's why we call them as a stationary orbits. In first postulate only I explained you. So these orbits are called what? Stationary orbits. Why? Because this energy is not going to change. In these orbits, electron energy is not going to change, and it does not lose or gain energy. It does not lose energy, does not gain energy in the same orbit. When electron will move from one orbit to another orbit, that is another case. But when electron revolving in the same orbit, in such case electron neither lose energy nor gain energy. Next point regarding Bohr postulates in that. So before going to start this postulate, I would like to explain one small concept here. So this is atom. So this is a nucleus. So in this nucleus, this is a first orbit, and this is second orbit, and this is third orbit, like this. So which is near to the nucleus, that orbit will have lower energy, and which is away from the nucleus is having higher energy. So it is having n is equal to 1, n is equal to 2 and n is equal to 3. So n is equal to 1 having lower energy, and n is equal to 2 having higher energy, and n is equal to 3 having high energy than these two. So n is equal to 4 having more energy than 1, 2, 3, 4, like that. So here after this you see this next postulate. The electron will move from a lower stationary state to a higher stationary state. Electron will move from lower stationary state to higher stationary state. When electron is moving from lower energy level to higher energy level, or lower stationary state to higher stationary state, it will absorb energy. Why? Because it need to move from low level to high energy level, means it needs some energy. So that's why it will be absorb energy when it is moving from lower energy level to higher energy level. Means if electron is revolving in first orbit, it want to move from first orbit to second orbit. In such case, it will absorb energy, right? So but when it is revolving in the same orbit, it will neither lose energy nor gain energy. But here electron is moving from lower energy level to higher energy level. Completely one shell to another shell it is moving. So for that purpose it needs some energy. right? So when the required amount of energy is absorbed, means when it is moving from lower energy level to higher energy level, it needs some energy, it will absorb energy. And next point, by electron, it absorbed by electron. When the electron jumps back to high energy level to low energy level, when electron is going to reach from second energy level to first energy level, in such case, whatever the energy absorbed by the electron, that energy will be released. Okay, here lower energy level, it emits the same amount of energy. How much energy it absorbed when it is going to reach from energy level 1 to energy level 2, the same amount of energy it will release when it is going to move from second energy level to first energy level, right? So this energy level, how much energy is absorbed, then how can we calculate? The difference of second energy level and first energy level will be calculated by using this formula. So here you see the frequency of the radiation absorbed or emitted when the transition occurs, means 2 to 1 or 1 to 2. This transition frequency can be calculated like this. Occurs between two stationary states. The difference in the energy is known as what? Delta E. E means energy, delta means change in energy. Actually, delta E will be calculated by using E2 minus E1 formula. Higher energy minus lower energy. But we know that E is equal to H into nu. E is equal to H into nu. So just you substitute this formula here. So E2 minus E1 and change in energy is equal to what? H nu 1 is equal to H mu is equal to what? E2 minus E1. So nu is equal to what? E2 minus E1 by what? H will come. So this is the formula. Nu is equal to delta E by H will come. Nu is equal to delta E by H. Delta E stands for what? So E2 minus E1. So by using this formula we can calculate energy, frequency of the transition. So this is complete information regarding Bohr atomic model.